This video is about applying trig ratio in solving word problems. Alright, let's get into it. From a lookout point 120 meters above sea level, an observer sees two ships sailing due east at angles of depression of 37 degrees and 21 degrees respectively. How far apart are the ships? Now, there are several ways you could do this question, but the focus is using the trig ratio. So let's do that. Again, you're going to draw a diagram to represent the information here, okay? So here is your 120 meters above sea level. This is it, okay? This is the sea. So let's draw the sea. This is the sea. And it says, so let's put our 120 here. So it said from a lookout point 120 meters above sea level. So this is the sea. This is 120 meters above sea level. So the observer is here. Sees two ships sailing due east. So this is east, okay? At angles of depression of 37 degrees and 21 degrees respectively. So I'm going to connect this. Okay? So this is your 37 degrees. You would have seen this ship. So he's here and you look at this ship here. And then you look a little further and sees this ship at 21 degrees. So that is your diagram. Now remember that when a vertical meets a horizontal, it meets at right angle. Okay? Now I'm going to label my diagram here just for the sake of being clear with whatever we are working now. So if I call this part here A, I could call this B, I could call right here C, and I could call right here D. Okay? I label it that way because I have two triangles. I have triangle ABD, which is this small triangle, and I have the bigger triangle, the outer triangle, which is ABC. Okay? Now, I'm going to break this thing apart. So let's put my diagram here. And I'm going to pull the diagram apart. So my first diagram is I'm going to use a smaller triangle first. So this is triangle A, B, D. This triangle here. Okay? So this would be 37 degrees. And right here would still be 120. So this is 120 here. Okay? Now, I want to find this distance. I want to find the distance AD. Because if I know what is AD, and I know the overall distance AC, then I can find this distance here. This is the distance between the ship. Okay, this is how far the ships are apart. Okay, so I could simply subtract this AD from the total distance AC, and then I would have found the distance between the ships. Okay, or how far they are apart. So I'm going to find this distance first. Now, remember, the first move is to label your diagram. Label your diagram. Okay, so the side that is across from your including angle, this is your opposite side. The side that is across from your right angle, that is your hypotenuse. And the side that meets the hypotenuse to form the angle, that is your adjacent side. Now, because I want to find the adjacent side, AD, and I have the opposite side, so I have the opposite side, so I write O for opposite. And I want the adjacent side, so I write A. So I go back to my Tor, and that would tell me that I want one with O and A in it, that is tan. Tan is the only one that has O and A in it, okay? So I would find tan of this angle, which is 37 degrees, equals opposite, which is 120, divided by adjacent, I'm going to call that AD. Okay, so I want to get rid of the AD from the denominator, so I multiply both sides by AD. Alright, so these would cancel. So now I have AD tan 37 degrees equals 120. Now I want to find AD, so I divide both sides by tan 37 degrees. Alright, so that part would cancel. So AD equals, and I can put this in my calculator as is. Make sure your calculator is in degrees. Okay, so I put 120 divided by tan 37, tan 37, and that would give me 159.25, but I'm going to keep that to the nearest whole, so that would be 159. So this is 159 meters. Okay, so this would be this length. Now that I've found it, I'm going to put it on my original diagram here. So I'm going to put it here. This is 159 meters. Okay, that is from here to here. Alright, now I'm going to draw my next diagram. So my next diagram would be my overall triangle, my outer triangle. So this is my outer triangle. This is A, B, and then C. And I would have angle C there, which is 21. I would still have my 120. And I want to find this part here now, AC. Okay? So again, this part would be your opposite side because it is across from your including angle. So this would be your opposite side. This would be your adjacent side. Okay? Because this is your hypotenuse. So again, I want one that has opposite and adjacent, and if we go back to it, we realize that was tan. Okay, so I'm going to find tan of this angle. So it is tan 21 degrees equal opposite, which is 120, divided by adjacent, which is AC. Again, if I multiply both sides by AC, because I want to get the AC from the denominator, this would cancel that. So what I would have now is AC tan 21 degrees equals 120. And I divide both sides by tan 21 degrees. That would cancel. So AC would equal, and let's put this in our calculator here. So it is 120 divided by tan 21 degrees, and that would give us 312.61, but I'm going to keep that to the nearest whole as well, so that would be 313. So that would be 313 meters. Now I'm going to put it on my larger diagram just the same. So my entire distance here, let's use a different color for that. My entire distance from here to here, that is 313 meters. So therefore, to find this distance, so let's put it here. So therefore, DC, which is what we want to find, DC would equal to this entire distance AC minus this distance here AD. Okay? So DC would equal to AC, which is 313, minus AD, which is 159. So DC would equal to, let's see what that is, 313 minus 159. So that would give us 154 meters. So that would be the distance between the ships are. That is how far the ships are apart. Okay? Alright. Have a fantastic day.